YouTube videos and reference material that's online. So if you don't want to talk to anyone, you can do this actually on your own and watch videos. It will actually literally show you how to do it. Okay. So let's turn off this slide here. It kind of is glary for the people that are in the classroom here. Okay. So let's go ahead and continue on. All right. Now, let's say you have the moles of this stuff and you want to find the grams. So we want to go moles to grams. Now, if you look at this, again, it's the same substances. So if you found out what the molar masses previously were, then you don't have to do it again. And I think I remember I think water I already know is 18, this is 74, this is 164, if I remember correctly, for calcium nitrate. Okay, so let's go ahead and do those on our LFD, so we can get. All right. So let me write these down before I forget. So what I want to do is share screen. So let's get rid of this first. It was 164. So I'll that. 64. So let me write this down before I forget. So we had calcium nitrate and calcium nitrate. That was 164 grams of CaNO32 for every mole of CaNO32. We also had potassium chloride, and that was 39 and 35, so that was 74 grams of KCl per mole of KCl. And finally, we had water, H2O, and that was 18 grams of H2O for every mole of H2O. Okay, so those are the molar masses that we figured out for those three that we need. Okay, the first question was, what if you're given 3.75 moles of H2O, right? Put one in anything. Okay, I know I need moles of H2O on the bottom to cancel out moles of H2O in the top here. And then I have to have grams of H2O, right? Because that's what I'm looking for, grams of H2O. Well, that's the molar mass, grams per mole. Well, what is it for water? It is 18. Remember, it's right here, 18. So what 18? Moles of H2O cancel out, and it's just a matter of taking out your calculator and multiplying that out, right? So we got 2.75 times 18, and we get 67.5 grams of H2O. Okay, so that's the first one. And then the second one is 0.25 moles of potassium chloride. KCl. Well, we do the exact same thing, nothing different. It's a repetition sometimes, but sometimes you need repetition to make sure you're doing this right. Right? It's just like, you know, if you're a basketball player, you want to get good at free throws, right? You sit there on the free throw line and just do nothing but free throws over and over and over again until you start getting them correctly. So this is 0.25 times 74 is 18.5 grams of KCl, right? 0.5 grams of KCl. And finally, the last one, or at least the last one I'm doing for you guys, you have 4 moles of calcium nitrate. Right? One underneath, and again, we want moles of calcium nitrate on the bottom and grams of calcium nitrate on top. And previously, we figured that out to be, where is it? 164, right? So 164. Okay. Moles cancel out, they will be with grams. So 4 times 164. 656. 656 grams of calcium nitrate. Okay. Let's see, that is 56. Okay, so those are the first 3 answers for that problem set number 7. Okay, let's double check, make sure we got the right answers here for that. And then stop the share here. And we'll go ahead and share our PowerPoint. Okay, there you go. Let's go ahead and see how we did. First one we got was 67.5 and we 67.6, right? Now, why is that a difference? Because we rounded off. You know, that whoever did this, the answer did not round it off, but that's okay, right? So if there was a multiple choice and you pick which answer, you're not going to get an answer where it's like 67.5, 67.6, 67.7. No, they're going to be widely different. So you'll know that that is the one the choice that you will get. Okay, the next one we got was 18.5, and the answer here was 18.6. Good, close enough. Third one we got 656, and here we got 656.4. No big deal. Okay, as long as they're close, that's all we're looking for. And then what I want you guys to do is go ahead and on your own do 4, 5, 6, and 7, and make sure you can get those numbers. And again, if you can't get those numbers, please come see me. Please talk to me. If not, you know, look up stuff on YouTube because there's plenty of them. Look online. There's plenty of answers online. But if you want to come, you know, talk to me during office hours, you can. That's not a big deal. Or ask me questions in class. It's just as easy. Okay. All right. Let's continue on. Now, remember, 1 mole of something, when we're talking about the weight, is the molar mass, right? 1 mole will equal to the molar mass in grams or something, and it's 6.02 times 10 to the 23rd units. For example, if I have 1 mole of carbon, that's going to be 12.01 grams. And you're going to have 6.02 times 10 to the 23rd atoms of carbon. Now, we use atoms when we are talking about individual elements, all right? So anytime we're using elements, it's going to be atoms. Now, if we have 1 mole of water, that's going to be 18 grams and 6.02 times 10 to the 23rd molecules of water. Now, why do I say molecules? Anytime you have covalently bonded compounds, remember what a covalently bonded compound is? It's a compound that consists of non-metallic elements, okay? Remember, hydrogen is non-metallic, oxygen is non-metallic. Okay, so when we have covalently bonded substances, you use the terms molecules because these do exist in individual molecules. Now, when you're using ionic compound, remember, ionic compound is compounds that are formed between a metal and a non-metal. They use electrostatic attraction to hold them together. We use the term units. Now, why do we use units instead of molecules? Because we don't know which atoms are really attracted to which other atom, or which cation is attracted to which anion, because they are stacked in these crystalline structures. So really, they're attracted to everything that's around it. The thing is that if you break down this substance into its most basic pieces, that's what you're going to get is those units. So that's what we call units, okay, for the ionic compounds. All right, so let's continue on. Now, if you want, it's sometimes easier just to memorize this kind of pieces of the mole. Now, you don't need to do this, okay? Because you guys will get to use your calculator. In the past, they did not allow calculators on the state test. So this way, you know, I tried to teach people how to figure things out real quickly so they don't have to, you know, do paper and pencil. And I'm just going to go ahead and go through this. If you're giving remember, what's 1 mole of something? 1 mole of something is 6 times 10 to the 23rd. Or you don't have to worry about times 10, you just have to worry about the 6. So you're taking 1/4 of a mole or 1/4 of 6. What's the 1/4 of 6? It's like 6 divided by 4. And if you simplify that, it's 3 over 2. What's 3 divided by 2 is 1/2, 1 and 1/2. So that's why if you get a quarter of a mole is 1.5 times 10 to the 23rd, or 1.5 of the 6. If you get a half a mole, that's like half of 6, which is 3. So that's why it's 3 times 10 to the, 10 to the 23rd. Obviously, 1 mole is 6 times 10 to the 23rd. 1.5 mole is like 1 mole plus a half a mole, right? A 1 mole is 6, a half a mole is 3, 6 plus 3 gives you 9. So 1.5 mole is 9 times 10 to the 23rd. 2 moles is like 2 times 6, which is 12. However, we don't say 12 times 10 to the 23rd. It's another factor of 10. So we say 1.2 times 10 to the 24th. We have to raise the power of 10 one more time, so to the 24th. 2.5 moles is like 2 moles, which is 1.5 or 1.2, plus a half a mole, which is 3, right? 2 moles is 12. Sorry about that. And a half a mole is 3, right? 12 plus 3 is 15, but we don't say 15 times 10 to the 23rd. We say 1.5 times 10 to the 24th. 3 moles is 3 times 6, which is 18, but we don't say 18 times 10 to the 23rd. We say 1.8 times 10 to the 24th. We have to raise that factor because we decrease the factor of the 18 by a factor of 10, okay? Again, you don't have to memorize this, all right? But I'm putting it up here just in case. So some people who are really good at numbers, you'll get your answer really quickly, okay? And let's do that, for example, on the next one here. Okay, let's take a look at this. Determine the number of atoms in this amount. Okay, so let's go ahead and go over to our LFD to do that. Here. Share. Okay, let's get rid of this. Now that we're done with that. Okay, now the first question is if you have 109.88 grams of manganese, right? The question is how many atoms do you have? Okay, so the thing is, do I have a relationship between atoms and grams? No, I don't, unfortunately. However, I do have a relationship between atoms and moles, right? 1 mole of something is Avogadro's number of that unit. So 1 mole of a substance is equal to Avogadro's number of atoms. Avogadro's number is 6.02 times 10 to the 23rd. However, but I also have a relationship between grams and moles. So what I need to do first is change the grams to the moles and then the moles to the atoms. So this becomes like a 2-step problem. Okay, so I want to first change this to moles. So that means I need grams of manganese in the bottom and moles of manganese on top, right? So that's the molar mass. So how would I get the molar mass? Again, on the periodic table. Mn, manganese, right here. 54.938. I'm going to go ahead and round that off to 55. Okay. Back here. So this will be 55 grams here. Okay. All right. Now look at this. 109.88 is approximately 110. Right? 110. 55 will go into 110 2 times. All right. So I can do this. I've got a 2 up here. Okay. And now I got the moles of manganese. How many atoms are there? Well, we know that there are 6.02 times 10 to the 23rd atoms of Mn for every mole of Mn. Right? Now we got atoms of manganese, and that's what we're looking for. Now, this is 2 times 6.9. You can take a calculator out, but if you remember what I just said, if you have 2 moles of something, it's 2 times 12. What's 2 times 12? I mean, 2 times 6. Sorry about that. 2 times 6, it's 12. Right? So therefore, this becomes not 12 times 10 to the 23rd, but 1.2 times 10 to the 24th atoms of Mn. There you go. Real quick, right? Without having to take out my calculator. So that's the answer for the first one. 1.2 times 10 to the 24th atoms. Okay. Let's take a look at the second one. Have 3 moles of copper. Right? Oh, 1 atom, that's easy. That's Avogadro's number, right? Because we want 6.02 times 10 to the 23rd atoms of copper for every mole of copper, right? Moles cancel out. Well, what's 3 times 6? 3 times 6 is 18, but we don't say 18 times 10 to the 23rd. We have to say 1.8 times 10 to the 24th atoms of copper. There you go. That's number 2. See how quickly these can be done? And then the next one is we got 117.38 grams of nickel. Well, again, it's like the first one, right? We're given grams, I have to convert it to moles, and then using Avogadro's number to convert it to number of atoms. So I have to look up the molar mass of nickel, Ni. Nickel's right here. It is 58.693, so it's going to be 59. It's 59 grams. So that'll be 59 grams of nickel for every mole of nickel. So nickel cancel out. Now, 117.38. Man, I'm looking at 59. 2 times 59 is 118. Okay? 2 times 59 is 118. So it's pretty close. So I can estimate that this number is going to be 2. Right? So it's actually 2 moles of Ni. So that means it's 2 times 6.02 times 10 to the 23rd, right? Atoms of nickel per every mole of nickel. Right? Moles of nickel cancel out. Well, what's 2 times 6? It's 12. Again, we don't say 12 times 10 to the 23rd. We say 1.4. 1.2 times 10 to the 24th. Atoms of nickel. Right? So there you go. The first 3. See how quickly we can get those done? So our answers is 1.2 times 10 to the 24th, 1.8 times 10 to the 24th, and 1.2 times 10 to the 24th. Atoms of nickel. So let's go ahead and double check our answer on our PowerPoint. Let's go ahead and do that. Share our PowerPoint here. Okay. So the first one was 1.2. That's what we got, times 10 to the 24th. And the answer here is 1.2 times 10 to the 24th. The second one we got was 1.8 times 10 to the 24th atoms. 1.81, close enough, times 10 to the 24th. And then the third one, we also got 1.2 times 10 to the 24th. And it is, yes, 1.2. And then what I want you guys to do for the next four is to do it on your own and see if you can get these answers, right? If you can, right here, right, half a mole is, you can even look at this and get it, right? Half a mole, what's half of 6? It's 3. 1 mole, oh, it's 6. 59.8, what you will find is this is 1 mole, right? If you look up cobalt, this is the molar mass of cobalt, so it's going to be 1 mole. So it's 6.02. And this is 1.5. Well, what's 1.5 of 6? It's 9. So right there, boom, get your answer without actually having taken out your calculator, right? That's the reason why I was trying to teach people. But if you want to use a calculator, that's fine too. Not a big deal, all right? We are going to go ahead and stop here on the PowerPoint, because next up is the dreaded stoichiometry, but I need for you guys to do some practice. Okay, there are 3 assignments in Google Classroom. Okay, before you start, hemming and hawing and crying that there's too much work, you have until Sunday night to do them. I'll tell you right now, a lot of people finish them before the period is even over. And there are some people that just do it, finish the whole thing in the next day. All right. So it's not that it's real difficult. All right. There's 10 questions each on each sheet. So it's 30 total, but you can knock these things out really fast if you know what you're doing. Okay. So you go to Google Classroom. There is an assignment called Molar Calculations number 1, 2, and 3. For those of you that are online, please, this is what you need to do. This is everybody, not even the people online. What you need to do is download a copy of each one of those, do the worksheet. Then what you need to do is go to your student view to input the answer. So now you're not going to get credit just for doing it. You are going to get credit for doing it correctly. All right. You need to make sure you get the right answer. So that way, when you assess them online, you choose the right answers. Okay. So please assess them before Sunday night, 11:59 p.m. Sunday night. So that way you can get full credit for these assignments. All right. Otherwise, you're going to end up getting like half credit. Okay. Anybody have any questions on this? People online, do you have any questions? Can we count of 5? Okay. For those of you that are in the classroom right now, I have already printed out a copy of each one of those. So you can actually do the work in here. Get it done in here so you don't have to do it at home, all right? So worksheet 1, 2, and 3 are up here. So for those people that are in class right now, come on up, get a copy of each one and start the work. For those of you that are online, please go to Google Classroom and download the worksheet, start them, and then please assess them before Sunday night. So that's everyone. Please assess it's in your student view, okay? So look in your student view, you should see, worksheet 1, worksheet 2, worksheet 3 for molar calculations, all right? For those of you that are online, you don't have any other questions, you are free to go.